In chapter 7.2, it talks about parallel and perpendicular lines or linear equations. It also talks about how do you figure out an equation based upon a single point and a slope, and how do you figure out an equation based upon 2 points. And then finally we're going to solve some involving lines that pass through a point with a slope and that are parallel to and perpendicular to. So let's get started. What we first know is that with parallel lines, the slope will be exactly the same. So in parallel lines, up in the upper left-hand corner, you see it says m equals m. That means the slope of each of those parallel lines is the same. Let's take a look at example number 2 on the bottom of page 516. If you see in 2, it says y equals 3x minus 5 for A. For B, it's y equals negative 3x plus 5. For C, it's y equals 3x plus 2. And for D, it's y equals negative 1/3 x minus 5. What I'm looking for is identical slopes. I see that the slope for A and B is both 3, but A happens to be positive, B happens to be negative. But when I look at A and C, I see that the slope is both positive in both cases, and it happens to be 3. So that's my answer. Now, interestingly, if you look at the top of the screen there, for perpendicular lines, the slope of one has to be the negative reciprocal of the slope of the other. Take a look again at number 2, and you'll see y equals 3x minus 5. Now look at D. It's negative 1/3 x minus 5. And in fact, A and D happen to be perpendicular lines. Let's practice one of those again. Looking at number 6 on page 517, you have A equals 2/3 x minus 8. B equals y equals negative 2/3 x minus 6. For C, y equals 2/3 x minus 6. And for D, y equals 3/2 x minus 6. If we take A, then what we're looking for is the negative reciprocal of 2/3, which would be negative 3/2. Do we have negative 3/2? No, we don't. We don't have that anywhere. We have a negative 2/3, but not 3/2. Looking at B, we have y equals negative 2/3 x. Our slope being negative 2/3, the reciprocal of that would be a positive 3/2. And if we look at D, that's exactly what we have, 3/2. So what the perpendicular lines will be are B and D. All right, now we want to figure out, is a line parallel or perpendicular? And we look at number 10. In number 10, what we have here is 2 points for line 1. Those 2 points are negative 2 and 4. And the second point happens to be 1 and 8. For our second line, the first point is negative 1, negative 1. And the second point happens to be negative 5 and 2. Now, what we need to do is figure out the slope for each one of them. So let's take the first set of points. Remember our formula, m equals y2 minus y1 over x2 minus x1. In that first one now, we'll take 8 as being y2 minus 4. And then for x2, we have 1 minus a negative 2. What we have now is 4 over 1 plus 3, or 4/3. For our second set of points, writing the formula down again, x2 minus x1, what we have here is m equals 2 minus a negative 1 over negative 5 minus negative 1. Here in this case, what we get is 2 plus 1 over negative 5 plus 1. this case, m equals 3 over negative 4, or negative 3/4. So what we have here is a positive 4/3. What we have over here is a negative 3/4. We have the ingredients for perpendicular lines. The slopes are reciprocal, one is positive, one is negative. So now we've solved that. We need to figure out how do we solve problems where we have a point and a slope. And in the book, on page, I think it's 510, it gives you this formula that I have written down here. Y minus y1 equals m times x minus x1. That's that formula in the upper right hand corner. So let's take a look at number 16, where we have the point 0 minus 4. And we have a slope of negative 2. Using that formula, we'll go y minus, and y1 happens to be negative 4, equals m, which is negative 2, times x, which is, x minus x1, which is 0. What we get is y plus 4 equals negative 2x. And then subtracting 4 from both sides, we get this y equals negative 2x minus 4. Now that's one approach that you can use. However, I like to use a different approach, which is y equals mx plus b. That's our standard formula. And what I'm trying to do here is figure out what is b by plugging in every value I know. I know that y is negative 4. I know that the slope is negative 2. I know that x is 0, and then plus b. In this particular case now, negative 4 is going to be 0 plus b, or b is going to be negative 4. Going back to our original formula, y equals mx plus b, now if I substitute in the slope, which I know is negative 2x, and then b, which I now know is negative 4, I get the same answer. So I prefer to use that approach. And what we're going to do is another problem, only in this problem, instead of having the y-intercept point 0, negative 4, we're going to have a point someplace. If you look at number 24, what we have is minus 1, 2, and our slope is 3. If I use y equals mx plus b, then all I do is substitute in. Y is 2, m is 3, x is negative 1, plus b. I have 2 equals negative 3 plus b. Adding 3 to both sides, I now get 5 equals b. So going back to our formula y equals mx plus b, I now substitute in and I get y equals 3x plus 5. And if you use the approach that we have with that formula in the upper right hand corner, you would get the same answer. But let's go ahead and flip the page and take a look what happens if we have 2 points like we do in number 36. In number 36, what we've got is points and no slope. So the very first thing we need to do with number 36 is figure out the slope. The points are negative 5 and 3 and 4 and 1. So we figure out the slope is y2 minus y1 over x2 minus x1. Then our slope happens to be 1 minus 3 over 4 minus a negative 5. What we get then is negative 2 over 4 plus 5. And our slope happens to be negative 2/9. Whoa, that's kind of interesting. Now let's go ahead and plug that into the formula y equals mx plus b. Y, now, we can pick either one of the points, but I'm going to pick the second point simply because it has nothing but positive numbers. Y being 1, m being a negative 2/9, and x being 4 plus b. What I get is 1 equals negative 8/9 plus b. So I add 8/9 to both sides. And what I get is b equals 1 8/9. Now that can be written as y equals mx plus b. Y equals negative 2/9 x plus 1 8/9. But you'll find in the book what they like to do is write that mixed number as an improper fraction. So you'll see it written negative 2/9 x plus 17/9. So that takes care of number 36. If you can do 36, you can do all of those involving 2 points. Now what I want to do is take a look at some of the kind of story problems. I mean, not really, but we're starting with problem number 41 and working our way down. I've got 3 different examples that I want to cover so that I've covered everything for you. The first one happens to be number 48, which is a line that passes through the point -2, -4, and it has a slope of -3/2. This one should be easy for you to do because we just plug into the y equals mx plus b, those things that we know, y being -4, equals our m is -3/2 times x, which happens to be -2/1, plus b. And -4 equals a negative times a negative is a positive, and the 2's cancel out. So what I get is 3 plus b. Subtracting 3 from both sides, I get -7 equals b. And therefore, my formula is equal to -3/2 x minus 7. Okay, so that's a sample of that kind of problem. You shouldn't have any problem or difficulty with those problems. In the next problem, what I'm going to do is just show you the setup for the next one. Because it's so easy, I'm not going to solve the whole thing. We're going to drop down and we're going to look at number 56, which is there's a line passing through the point -4, 3. And it's parallel to this equation. Y equals -2x plus 1. Well, if it's parallel, then what I know is my slope happens to be -2. So what I do is I go into that y equals mx plus b, and I substitute for y, I substitute 3. For m, I substitute a -2. For x, I substitute a -4, and then plus b. I get 3 equals 8 plus b, subtract 8 from both sides, and I get b equals -5. And now we just do y equals mx plus b. Y equals -2x minus 5. That's simple. I said I wasn't going to solve it, and I guess I did, so we'll probably solve this last one. In the last one, which is number 58, what we have now is a line that passes through the point -2, -1. -2, -1. And it's perpendicular. That's the symbol for perpendicular. By the way, the symbol for parallel is this. Just thought I'd throw that out there for you. Anyways, it's perpendicular to a line where the equation is y equals 3x plus 1. Well, in this particular case, then the slope is equal to 3. But a perpendicular slope, how you like my symbology there, would be negative, the inverse, which is 1/3. So when we set this up, y equals mx plus b, taking the point y being negative 1 equals that negative 1/3 times x, which is negative 2, plus b. What we get is negative 1 equals 2/3 plus b. Now we subtract 2/3 from both sides. On the left, we have negative 1, we have a negative 2/3. That's a negative 1 2/3 equals b. And going back to our y equals mx plus b, we have to remember y equals, and the reciprocal of that, our slope now is going to be this, not the 3, but the negative 1/3. Negative 1/3 x minus 1 2/3, or y equals negative 1/3 x minus 5/3. So there you go. That's all about parallel and perpendicular linear equations. We'll do graphing inequalities coming up next.